All right. Good morning, everyone. Um, Today we are talking about Ethernet switching. That is module 7. All right. In today's class, we will talk about Ethernet frames. Like yesterday, I told you, the protocol data unit at the data link layer is called frames. So we'll be talking about Ethernet frames. We'll also talk about Ethernet MAC addresses. What is a MAC address? We also talk about MAC address table. And the final one is switch speeds and forwarding methods. I hope you guys can hear me well.
Yes, at my end, it's okay. I can hear you clearly.
All right. All right. Let's start with Ethernet frames. This is the OSI model, the Open System Interconnect OSI model. The idea, like I was trying to explain, why do they come up with this OSI model is to enforce standardization among network vendors. That is why the bodies that are responsible, like IEEE, the ISO, the ITU, and etc., I mean, um, they developed this standard that is called the OSI model to enforce standardization among vendors. Before this OSI model, different vendor equipments, some of the vendor equipments will not be able to communicate. Like I was trying to give an example. You may go and you may have your computer and the computer is a Dell computer, okay? You go and buy HP processor or HP network interface card and they will not be able to work together. There will be no compatibility, okay? Or you have a router and or a switch from, let's say, Huawei, you went and buy a Cisco access point, you'll have trouble for them to communicate. So in trying to stop this, that is why they developed this OSI model so that, I mean, vendor equipments can communicate without trouble. Is that clear? Hello? Hello?
Yes, yes, we are getting you.
I hope that is clear, right, about the OSI model. The whole idea is for vendor equipments to be able to communicate,
Communicate.
interoperability, yes. Okay, so now, like we started initially, we talked about the physical layer already. Still now we are on the data link layer. If you look at it yesterday, I told you the data link layer is divided into two subcategories also. The first one is LLC, that is the logical link control, and the other one is the MAC, media access control. Okay.
Yeah.
So you can see the data link layer sub layers, LLC. The LLC is the interface to the upper layer, that is the network layer. It places the network informations in the frame. It places the network information or which type of network protocol. It puts that one on the frame. And the MAC sublayer is used for encapsulation and the media access. We have different types of media accesses. You look at it, sometimes your media is copper, sometimes wireless. You understand what I mean? So the MAC sublayer is responsible, for that media access, what type of media access you're using. If you are using fiber, or you are using copper, or you are using wireless media. So the MAC sublayer is responsible for that data encapsulation and media access. Again, the data encapsulation will include the following: Ethernet frames, Ethernet addressing, and Ethernet error detection. The Ethernet frame, that is the structure, the internal structure of the frame. The Ethernet addressing takes care of the source and destination MAC address. Like I told you, at layer 2, that's the data link layer, for the frame to be able to be delivered, the sender must know the destination MAC address. Okay, and then the frame also take care of error detection. Like I told you yesterday, there's something called FCS, frame check sequence. That frame check sequence will check the frame and determine whether the frame is corrupt or not. So that is why the FCS is responsible for error detection, but not error correction. So the media access sublayers, yesterday we talked about all this media access. First one was carrier sense multiple access with collusion detection, and carrier sense multiple access with collusion avoidance. These are all different types of media access. If you are using a media access in a switch, in a hub environment, in a hub operates in half duplex mode. So the media access is communication has to take place one at a time. If all the equipment, all the computers connected in a hub environment want to send information at the same time, collusion is going to occur. So the MAC sublayer is responsible for the type of media access. So this is an example of an Ethernet frame, guys. This diagram you're seeing here, the Ethernet frame is 64 bytes in length. That is the normal frame, is 64 bytes in length. You can see. It has a source, it has a destination MAC address, source MAC address, the type or the length of the frame, the actual data, and the frame check sequence. This is the normal range for Ethernet frame, starting from source and destination. That's the normal range. Okay. The preamble here, or the SFD, is responsible for synchronization, or to show you the start of the new frame, like it indicates the beginning of a new frame. So normally, like from here, the minimum size of the frame will be 64 bytes, but the maximum size of the frame is going to be 1,518 bytes. So if a computer receives a frame and that size of the frame is less than 64 bytes, the computer is going to drop that frame, because the computer will see that the frame has been tampered, it is corrupt. Maybe it has encountered collusion. So at the same time, if a computer receives a frame that has a size bigger than 1,518, that frame is also going to be dropped or discarded, because the computer will see that this frame is not normal. So the minimum size of a frame is 64 bytes, and the maximum can be 1,518. Okay, so we move to another topic, that is Ethernet MAC address. What is a MAC address? MAC address, some people call it hardware address, or some people will call it born-in address. Some call it physical address. There cannot be any communication in networks without MAC address. MAC address is a physical address, while IP address is a logical address. That's how you put it. So MAC address is a physical address, or you can call it born-in address or hardware address. Every network device comes up with a MAC address. If you are sitting in front of a Windows machine, you can go to the command prompt and type ipconfig /all. If you do that, you will see the MAC address of all the network interface cards you have. If your computer has more than one network interface card, each network interface card will have its own MAC address. So if your computer is a Linux computer, you also go to the command prompt and type ifconfig, that is interface configuration, ifconfig. You press enter, you will see the MAC address of your computer. Let me try. I'm not using a Windows machine, so This is my machine. It's an Ubuntu. It's a Linux-based machine. I hope you're seeing my screen, right? Are you seeing my screen? Are you guys seeing my screen?
Yeah.
Okay. So I just want to show you from the Linux machine, you type ifconfig. This is going to show you all the network interface cards. You can see I have the logical loopback interface. All these are interfaces I have. So this is the MAC address of my computer. You can see it here. Let me highlight it. This is the MAC address of my computer. Okay. So if you are using a Windows machine, you can try it with your Windows machine. This is the command, ipconfig. Okay. This is the command for your Windows machine. All right, let's go back. So the MAC address or the physical address or the hardware address, it is 48 bits binary value. The length is 48 bits. That 48 bits is a hexadecimal values. It's hexadecimal number. That means it has some, alphabets also. From 0 to 9, A to F. Okay? MAC addresses or hardware addresses is 48 bits in length, and it is represented in hexadecimal values. Is that clear? So every device on the network, for it to be able to communicate, it must have a hardware address or a MAC address. Okay. Furthermore, MAC addresses, like I told you, is a 48 bits. And that 48 bits is divided into two. One half is 24 bits, and the other half is another 24 bits. What happened? The first 24 bit is called organizationally unique identifier. You can see it here. The first 24 bits is called organizationally unique identifier. The second or the last 24 bit is called a vendor assign. How do I put this in our own context? For instance, this MAC address, the organizationally unique identifier is issued by IEEE. IEEE. Right. How do we put it? Let me put it in the Gambian context. For instance, in Gambia, we have about how many GSM operators? How many GSM operators do we have in the Gambia? Can anybody help on that?
We have 4.
4 GSM operators, okay. And all these GSM operators, the procedure is you have to register with PURA, right? Do you know PURA? Public, I think it's called what? Utility and Regulatory, I don't know, affairs.
Regulatory authority, yeah.
Yes. So all these GSM operators have to register with PURA. And one thing is there, PURA will have to give them, let's say, the first digit. Let's say, we all know if you see a number and it starts with number 9, you know automatically that's a Gamcell line number, right? If you see a number that starts with 7, you know it's a number from Africa. So we will say that number 9 and number 7 will be issued by PURA. So the remaining bits will be given by Gamcell or QCell. Is that clear? Like my number is 9992609. Automatically you will know the number 9, first 9 is issued by PURA. The 9992609 is given by Gamcell. Is that clear? Hello?
Yes.
Is that clear?
Yes,
okay.
yes, that's
So in this context also, MAC address is 48 bits. The first 24 bits is called organizational. That, like the number 9, we identify it as a Gamcell number. So here also the first 24 bits is an organizationally unique identifier. So all the manufacturing companies who are manufacturing layer 2 devices will have to get a unique 24 bits from IEEE. That is going to, so if you see that if you see that MAC address, by looking at the first 24 bits, you'll be able to tell that this layer 2 device is manufactured by Cisco, or is manufactured by Huawei, or is manufactured by Intel, whatever, HP or whatever. So the second 24 bits, the vendor himself will have to assign that. Is that clear? Can we move on?
Yeah.
All right. So how do they process their frames at layer 2? How those two computers, you can see these are examples. So I'll do a lab on this for you to see how do they communicate on this. If a computer is connected, you can see these computers, H1, H2, H3, and H4, are all connected on the same switch here. So that means these computers are on the same local area network. Okay? That means all these computers are on the same local area network. So if these computers want to communicate, let's say H1 want to communicate with H2, and there is a noise coming from GRTS, right?
Okay, sorry.
You can mute yourself, fine, thank you. Okay, it's very clear now. So if you look at these computers here, H1, H2, H3, and H4, these are connected on the same switch. So they are on the same local area network. So if this H1 want to communicate with this H1 will know the IP address of H2 before they can communicate. Okay? But will not be able to know the MAC address automatically. First, what H1 will do is, H1 is going to send a broadcast on this network. And that broadcast, the H2 will receive, H3 will receive, and H4 will receive. But in that broadcast message, maybe H1 is going to say, okay, I want to talk to H2. Who is H2 in this network? Can you please send me your hardware address? That is a broadcast, but all these computers will receive that broadcast. But H3 and H4 will not respond because they are not H2. So only H2 will respond, and H2 is going to respond with his hardware address. So the next time H1 wants to communicate with H2, it's not going to send a broadcast, it's going to send a unicast message directly, because now H1 knows the name of H2 and also know the hardware address. But when you get to the practical, you'll understand it fully. Okay, just like if I want to communicate with one of you in the classroom, maybe I got your mobile number, but I don't know your name. And for us to be able to communicate comfortably, I must know your number and your name. Because believe me, if I call you and I cannot identify you, you will not be comfortable to talk to me. Will you be comfortable? No. So maybe when I call Comfort's number for the first time, I'll say, hi, who is on the line? Can you please identify yourself? Yes, I'm Comfort. Okay, fine. Then we begin communicating, for instance. So, but when we get to the lab, you will understand this more, how those switches, how those computers communicate within the local area network. So the different types of communication here is, we are seeing a unicast MAC address communication. Unicast MAC address communication is one-to-one communication. That is, if I know your if I know your MAC address, I'll be able to, and I know your IP address and stuff like that. You can see how the frame look like. Right now, there is a unicast communication here, one-to-one. So this frame is coming from H1. It has the destination MAC address and the source MAC address. It also has the source IP address and the destination MAC IP address. So you must have these informations before you can communicate to somebody one-to-one. But if you have the source IP and the destination IP, but you don't have the destination MAC address, you cannot communicate one-to-one. It has to be one-to-many. You must send a broadcast first. But here the complete frame is finished. You have this destination MAC, the source MAC. You have the source IP, destination IP, the data, and the trail. This is the complete frame. You can see that is a one-to-one communication. It's called a unicast communication. Then we move to broadcast. That is, like I told you, you don't know the destination MAC address. So you send a broadcast message. At this level, you don't know the broadcast, you don't know the destination MAC address. You only have the source MAC address, source IP, destination IP data. So you have to send a broadcast. You see this message sent here is received by all these computers. So it's a broadcast message. So the broadcast representation for MAC address is FF, FF, FF. So you need to know this very well. The broadcast MAC address, if you want to send a broadcast in the layer 2, is FF, 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 full. Everything is full. Is that clear? Move on. So now we move to multicast address. So multicast is when you are sending to a group of computers in the network. And the multicast, I'm sorry, the multicast address is 01-00-5E. When you are sending to a group of computers in the network. So I think I've told you this in the previous classes. How do you call it? Switches maintain a table called MAC address table. Every switch will maintain a table called MAC address table. What is that table for? That table is going to store the MAC addresses of computers and their corresponding ports on the switch. Like if I am connected with my laptop and my MAC address is AAA, and I'm connected to port 1 of the switch. So the MAC address table is going to contain a record of AAA is connected to port 1. If Comfort's laptop is using a MAC address of BBB and is connected to port 2 of the switch is going to store that information. And if LYC's MAC address is CCC and is connected to port 3, the switch is going to store that information. So that if Amisambu want to send a message to LYC, the moment the switch receives that message, the switch will know that LYC is connected to port 3 and the switch is going to send that information through port 3. Is that clear? Guys, is that clear?
Yes, that's okay.
Okay. All right, good. We move on. If you have any issues, please let me know so that we break it down, because people are not on the same level here. Okay, we have to cater for everybody. Don't feel shy to say you don't understand or repeat it, please. Okay? Don't feel shy to say we should repeat it or whatever. We want everybody to be at the same level. So there is something called ARP. You can see it here. ARP stands for Address Resolution Protocol. What is the essence of Address Resolution Protocol? ARP is a message, a protocol, a broadcast protocol that you will use to get the MAC address of the computer with the help of the IP address. Yes. Okay? You will use the MAC address, the IP address to get the MAC address. So that process you use ARP. ARP means for Address Resolution Protocol. Just like if you are sitting on your computer, you want to browse Facebook, like I gave you the example before. Facebook has a domain name called facebook.com, but computers will not understand what is facebook.com. So your DNS server will help you translate the facebook.com to a particular IP address. Okay? Computers don't know what is facebook.com. I'll show you this. Are you seeing my screen? Are you seeing my screen? Yeah, okay. So let me show you the IP address that Facebook is using. If you look at this, if I say ping facebook.com, you can see, guys, let's stop. So my computer is talking to facebook.com using this IP address. You can see. This is the IP address. So it's with the help of the DNS server, to translate this facebook.com to this IP address. So app also will use your IP address to be able to get the hardware address for you to be able to communicate. So I forgot to tell you one thing. MAC address table could also be called as CAM table. The full form for CAM table is called content addressable memory. So how does a switch learn and forward a frame? It's very important. The time is running, but how does a switch learn and forward a frame? Like that is the example I gave you when I told you Comfort is connected with this MAC address to port A, LYC on port B. That is how the switch will learn and forward the frame. That's the best example. Okay. You can see, because the switch will be listening and watching the traffic. You can see here, this is an interface of a switch, port 1, port 2, port 3, port 4. We assume that this A here passing is LYC and this is the MAC address. You can see 00 dash 0A. So the switch will learn that and store. This is the MAC address of the switch. You can see the port number is A and this is the MAC address of LYC. The next one is here, maybe Ami. This is her computer. And this is her MAC address. So the switch is going to listen and then enter that in the table. You can see port 4, this is the MAC address. Okay. So, okay, another final thing, we just do the speeds and forwarding method. Every switch port have a particular speed. If your switch is an Ethernet switch, or it's a gigabit switch, or it's a fast Ethernet switch, it is corresponded with a particular speed. But you can also change the switch speeds. We will do an example on that, how to change the speed of the port. Today we will do that. After we are done with this, that will take us like 30 minutes or so. I will just disconnect and then reconnect again, just do a small lap, okay, on that. But one thing is more important, frame forwarding. There is one thing called store and forward and cut through forwarding. Most switches will be either cut through or store forward, or the other one is called what? Fast forwarding or fragment free. Normally what happens in all this, the store and forward is going in the switch. The switch is going, the information that you are sending to another port, the switch is going to gather all the frame and store it in the switch first, in the switch memory, before forwarding it. That's a very slow process. And the cut through forwarding frame, before it's enter, before the switch will receive the entire frame. Let's say if the switch receives only half of the frame, the switch will start forwarding the frame. That one is fast, but the disadvantage is you will end up using your bandwidth to forward a frame to the destination, and upon arrival, you will realize that the frame is corrupt. But the store and forward is going to wait for the entire frame to be in the switch in its entirety, and is going to check on the frame before forwarding it. So if the frame is corrupt, the switch is going to drop it, okay? So there are different types of cut-through switching. You have the fast forward and the fragment free one. It's so fast. So the switch also have a memory. That's what we're talking about, the buffer. You have two types of method, the port-based memory and the shared-based memory. The port-based memory is going to store a particular frame from a particular incoming port to a particular outgoing port. But the shared memory is going to store all the frames in one big shared memory before forwarding them. We will look at also, this one also, we will look at it in the lab. That is the duplex settings. You can turn your port to be a full duplex or half duplex. You can do that. So in our lab, we will be doing duplex settings and speed settings today. So that is it. Duplex settings. You can see if the ports are operated in half duplex and full duplex mode, if you want to communicate simultaneously, there is going to be an accident, or you call it a collision, right? So there is also one thing called auto MDIX. It's very, very important. But right now, most of the switches that are coming with the auto MDIX enabled. Okay, what auto MDIX means? If you remember when we're talking about the cable types, we said like devices or similar devices use crossover cable, and unlike devices use straight through cable. Okay, so auto MDIX comes in, to take care of that situation. So if you enable auto MDIX, even whereas it should be a straight through cable, if you put a crossover cable, it's going to accept it. Is it clear? Auto MDIX is also very important. It is a feature that help us alleviate that trouble of cable types. Because I told you, similar devices use crossover. So, but with the help of auto MDIX, even if you use a straight through cable on a similar devices, it's going to adjust to it. If you look at the reading here, it says connection between devices once required the use of crossover or straight through. So that is all. I think our time is going. So what I will do is I'll have to take a 10 minutes break, and I'll share another link for us to do the lab. Okay. So guys, thank you so much for